AssetAsyst is an asset management and inspection software product developed internally by pitt&sherry. Our engineers use it to help them deliver their projects, but we also license it to external clients, such as local governments and state road authorities. I'm Adam Collings, one of the senior developers of AssetAsyst, and I've been involved with the product in one way or another for about the last 15 years. AssetAsyst has a proud legacy of over 20 years. The software has come a long way during that time, but it's the future that really excites us, as we look toward a fully web-enabled, GIS-centric client portal for the management of road corridors with associated bridges, street furniture, and other assets. The philosophy of AssetAsyst is driven by 3 points: engineering and technical advice, which means putting our intellect into the software, but also working with users to provide engineering services along with the software. Predictive insight, managing assets with the future in mind, using tools such as our predictive modeling. And risk clarity. We have a number of features to help us with this, such as our risk score calculator. The core focus of AssetAsyst is the management of road corridors, taking into account road, footpath, bridge, and culvert assets. But you can see the software is flexible enough to be used for a variety of different asset types. You can see here that we've used the software for bus shelter, flood levies, and gates, just to mention a few. AssetAsyst has recently moved into a cloud-hosted environment, which makes collaboration easier. Both pitt&sherry and the client can log into the system. We can provide the data, such as inspection results, and perform analysis, while the asset owner can log in, view the data, and run their own reports. If we look at a structure asset, we'll see some of this functionality. This is where we store the basic asset level data. Bridges are a complex asset, so there's a lot of detail here, based on our engineering knowledge. But if we look at an asset of a custom type that we've defined, you'll see that things are a lot simpler and more generic. User-defined custom fields enable the flexibility of the various asset types. You can see here we have multiple data types, such as text fields, drop-down lists, and date pickers. Assets can be divided into small parts. For example, a bridge is divided into individual components, whereas a road is divided into segments. For each asset, we can see the defects that have been logged against it, the inspections that have been performed or are to be performed, and the forward works that are planned to resolve the defects. Asset isn't just about logging data. It has advanced features for analysing the required barriers on a bridge, determining the loads of heavy vehicles, and predicting the future condition of assets. It also allows a financial management of assets, including depreciation. We have a mobile solution for conducting inspections in the field. The AssetAsyst mobile app runs on Android, both phones and tablets. Let's have a look at that in action. On this device, we have inspection packages for a number of different asset types. Let's open one of them up. We have 2 types of inspection here, a defect inspection and a condition inspection. We'll open the defect inspection. We have some basic header information and a photo. On the Units tab, we can see the components of this asset. We can simply tick them to say they've been inspected, or mark them all in bulk. We can also open them up to see further details, or add a defect. The defect inherits the GPS location of the asset, but we can override this, which makes sense for assets that cover a wide geographic area. We choose a defect type, an optional repair recommendation, and a priority. The priority can also be set automatically from defect type. You'll see that the app has pre-filled the defect and repair descriptions for us, which saves a lot of typing on the small on-screen keyboard, making data entry nice and easy. but we can edit these suggested values to customize them as much as we like. I don't know about you, but the less typing I have to do on a little phone, the better. Of course, you can also use the built-in voice recognition technology on your phone. Concrete shows evidence of spalling. We can take a photo of the defect, and this is very useful because we're taking the photo on the same device that we're using to log the data. That means that the defect is straight away associated with the data that it relates to, so we don't have to go through a matching process later on. We can see all the defects for this inspection on the defects page. You'll see that all of this is GIS enabled. If we click Open Map, we'll see the red marker, which is the defect we just logged. We can even ask the software to navigate us to the asset location, which can be helpful if you're inspecting remote assets that you've not been to before. And this is using the inbuilt navigation feature on the phone, but it's presetting the from and to locations for us. We can also do a condition inspection. In this case, we need to rate the condition of each component on the asset. We break it up into percentages of the component that are in conditions 1, 2, 3, and 4, where 1 is near new and 4 is no longer usable. In this example, 75% of this component is in condition 2, but 25% has fallen into condition 3. As with the previous type of inspection, we can log defects to further explain the condition. As I mentioned, we can also create forward works plans for the assets. Defects can be grouped and assigned to a works crew. This then forms a works package which can be exported to mobile, and the works crew can use a simplified interface on the same app that the inspectors use to close out defects as they are resolved in the field. In addition, we support dynamic works for recurring or routine maintenance, as well as capital works. These are proactive, whereas the basic work order is reactive. As a result of these works, a number of defects will become irrelevant and can be closed off in bulk. But we're not doing these works directly in response to any individual defects. We have a variety of reporting options in both Excel and Word. But the most exciting thing is the new direction we're moving, which is the development of a client-centric web portal. Asset owners will be able to log into the system using their web browser. The new web application leverages modern web technologies, such as ArcGIS JavaScript, to present data via a GIS-centric interface. Users will be able to group assets into a road corridor. Our heavy vehicle module will then allow them to set a route along these corridors where the bridges support the required loads. Users will also be able to run their own reports and download them directly from the website. The new website represents a vast improvement in terms of usability, performance, and accessibility. Thanks for watching.